Hello, everybody. Today I'm going to teach you about parallel and series circuits before I'm going to take up the booklet. So I'm just going to build two circuits right beside each other and show you how a parallel and a series circuit work. So here I'm building a circuit with two light bulbs here. And put a switch, another wire. So that's one circuit. Then I'm going to build another one. Put one switch here. Then another wire in here, another switch in here. And the battery. Okay, oops, I forgot to build the battery here. So I'm just going to put two batteries here because we need a source. Okay, it's very ugly. Okay, it's okay. And I'm going to build another wire here and another light bulb. So if you compare this circuit with this one, if I close the switch in here, you can see there's, like, imagine this electron here. It goes to this light bulb and then moves to the other light bulb, and then it keeps going and eventually comes back in here, right? So there is no other way. So for example, if this is your school and this is your home, for you to go from school, from your home to school, there's only one way. There's no other way for these electrons or electricity to travel. So that's what I call a series circuit. A series circuit is a circuit that there's only one path, one way for the electrons to go from one end of a battery to another end. There's no other way. I can't go over here, here, here. There's no other way. So one path for my electrons to move or my electricity to move, okay? So we're just gonna open the switch here. I'm coming to this one where it looks like a ladder, like it looks like there's two separate pathways, okay? So I'm just gonna close both switches and you can see electrons are moving faster, but I can go this way and come back, or I can go all the way to this one and come back. So in reality, there's two separate pathways for me to come from one end of the battery to go. So electrons have two choices. Electricity can go through this light bulb and come back, or this light bulb to come back. So that's why if I open the switch here, electrons say, fine, I'll still go through this one and come back. If I close this one and open this one, it says, fine, this one is working. I can go through that one. This type of wiring, which we call parallel circuit, is good for your house, for school, for factories, because look what happens to the light rays. They both give the same light, right? Very bright. You can see the light rays are, but if I put the same light bulbs in a series circuit, the light is not as much as this one. This is a lot weaker. Why? Because if this electron gets, like, imagine $100 from the battery, it has to go and spend $50 on this light bulb and $50 on this light bulb. So together it makes $100. but it has to share. Sharing means I have to go through this. So if I have $100, I better save 50 for the first one, 50 for the second one before I go back, right? Here, the electron says, I don't care. I got $100. I don't need to go to both light bulbs. So when I go here, I'm going to spend $100. So if I'm going here, $100. So the electrons either go through this light bulb and they come back, or they go through this one. They don't have to share like this one. So in a parallel circuit, we don't share. Now that $100 I talk about is the power that a battery gives. So I'm just going to measure that power, like how much energy my batteries are giving me. So if I put this to the two ends of the battery, so if you get a negative number, it's because the red has to be there, okay? So what I'm measuring, I'm putting this to the two ends of my batteries, and what do I read? It's called 18 volts. 18 volts is the energy available from my battery, right? So two batteries, 18 volts. So when I come here for one light bulb, how much energy I lose? 9 volts. How much energy I lose here? Another 9 volts. So that's what I mean by sharing. Means 18 here, but 9 here, 9 here. That's how the energy is shared when I have a series circuit. Now let's look over here. So I come to the two ends of the battery. What do I get? Gotta be connected. 18 volts again. Same as this one. Two batteries, 18. But when I come here to measure how much this light bulb is going to have, 18. How much this one is going to have, 18. So you can see each one will get 18, not 9. But when I have a series circuit, each one got 9. So that's why they say the series circuit, the potential or like a difference or the energy of the battery is shared. In parallel, they're not shared. Nothing is, the pressure is not shared. So now I'm going to use another one. It's called current. What is a current? Is these little bullets, like the little blue light, blue dots that you see, okay? So we're going to bring the current right where the battery is. And the current is showing me 3.60, right? This is the number of electrons or the electricity that's passing through the light. Okay, if I could sit and count, 1, 2, 3, 4, 5. In every second, I will have 3.6 electrons, whatever. So if I bring this one here, what do I get? I get half of it. When I bring it here, I get half of it. Why? Because this, when it comes to here, half of it goes into the first light bulb, the other half goes to the second one. They divide. That's why they don't have to share. They become two separate ways. I can go to school and come back this way, or I can go to another school. They don't have to share. Now I'm bringing this one here. Let's look at the battery here. Okay, so this one is very slow. I don't know if the batteries are connected or not. Let's see what happens. I'm going to change that to, what would be 3. Well, I want the current. Just 1 second. 9 volts. So I'm going to put this here, measure. So the current here says 1.35 amps. Okay, so this is the current I'm getting. So the other one, it became half. This one, if I bring it here, 1.35. Bring it here, 1.35. Bring it here, 1. Because the same electrons have to go through the same thing, same electricity. Well, here 3.6, here 1.8. That means half goes here, half goes there. Here, no. Everywhere I bring, I get the same number. So same current for a series circuit, different voltage. Here, same voltage, different currents, okay? So that's what is the difference between a series and parallel. So if I just completely open the switch, both light bulbs will die, right? Not work. Just like the Christmas lights or the street lights, they all come together on or all off, all on or all off. Here, one is off, the other one's on. One is off, the other one is on. Now what I want to do, I want to add another light bulb and see what happens. Okay, so I'm just going to add another light bulb in here. So now I'm going to have how many light bulbs? 3. Do you think I'm going to have more light or less light? Less light. Why? Because I have to share this voltage now with 3. So if I bring my voltmeter now, look. So here you have, again, 27 volts. Now what's going to happen? You're going to have 9 here, 9 here, and 9 here, right? So it has to share the same voltage and divide it. If I just bring one more light bulb here, what do you think is going to happen? Right? Let's see. So I'm just going to add another bulb here in parallel. So if I add another light bulb here, right? Is there any difference? No. So I added another light bulb. It didn't become less bright. It kept the same brightness. Why? Because this is a parallel circuit. So if I go to the kitchen, the light is on. I go to the washroom, the light is on. I go to my bedroom, the light is on. I'm not going to get less light. But if you have 3 of them together, yes, if you add more light bulbs, all the other bulbs will give up less light. Okay? So I hope everybody's clear about the difference between series and parallel. And I will go and now take up the booklets for you.